last time, laws of motion, right?
Yeah.
Okay. You're solving problems from the exercises. PDF file
No,
out.
sir.
You have to, but practice every day. Right. So friction force, you already have some idea, right? So what are the
Yes, sir.
difference between the left block and the right block?
In the right block, the block is in motion, and in the left block, it's not in motion.
Yeah. So
Or in the left block, the friction is equal to the force, and one's at rest and one's in motion.
yeah. So in the left block, the value of the friction force Fs, F stands for what? S in
Friction
F.
force.
Huh?
Friction with
Friction.
surface.
S stands for static. What is meant by static?
Rest.
Yeah. Static means rest, not moving. And K is what?
Kinetic. Kinetic.
Kinematic. Okay. So in the left, the value of the friction force, the maximum value is mu s into L. Okay. So it's a variable friction force. The value of the friction force will increase as you increase the applied friction, and beyond a certain limit, it will not increase. After it will start moving. Okay. So this Fk is a constant friction force. Okay. So when you say friction, this picture should come to your mind. Like suppose you say human, you can draw a picture like this, right?
Yeah.
Okay, similarly, when you say friction, this picture should come to your mind immediately. So this x-axis is the applied force, okay, and y-axis is friction. The value of friction is not constant. As you keep increasing the applied force, the value of the friction force will keep on increasing up to a limit. Okay, after that, you will start moving. Okay, and this maximum value is mu into n. Okay, and once it starts moving, there is a drop in the friction force, and it will stay constant. Okay, so this is kinetic friction, and this value is static friction. This you can actually experience if you have a book on a table. You try to push it with the one finger. Before it starts moving, you have to apply a force. And once it starts moving, the force required to apply is less. It will be easier to move the book once it's in motion. Okay, so that's because the value of the kinetic friction is less than the value of the maximum static friction. Is this clear? Yes?
Yes, sir.
Okay. Try to solve this problem. Just paraphrase the problem. The train is moving with an acceleration. Okay. So what is the net force acting on the block? So you suppose you draw the free body diagram of the block or box. It's a box. Okay. So what are the forces acting on the box?
Gravity.
Yeah.
Friction. And acceleration of the train, like
mg.
inertia.
Normal reaction. Friction force in which direction? Right or left?
Left.
Right, because see, since the train is moving like this block will try to move towards left.
Yeah,
Oh,
right.
yeah, right.
Okay, in some sense, friction force is the one just pulling the box. Okay, and the acceleration is in the right direction. Okay, the acceleration of the train is same with the acceleration of the box with respect to the ground frame. I'm fixing my frame to the ground.
One second.
Okay, so with respect to the ground frame, the box is accelerating with the same acceleration as out of the box because there is no slipping, there is no relative motion between the box and the train. So is that right? So now write the equation of motion or the equations in x and y direction. Y direction will give n equal to mg, right? What is the x direction motion equation? Bhavya? This is vertical equation, right? N equal to mg.
Yeah.
What is the horizontal direction equation? What is the net force is what?
Sine.
No, there is only one force in the horizontal direction, that is friction. That's equal to mass into acceleration.
Yeah.
This is Newton's second law. Okay, and what is friction force?
0.15.
No, mu s into n. Don't skip the steps. Okay, and mu s is 0.15. The normal reaction is mg equal to m into a. So this friction force is mu s into n when a is max.
Okay.
Because when it's moving, the acceleration is less, the friction force will not be maximum. Okay, so we keep on increasing the acceleration such that it's just about to slip. Okay, at that condition, the friction force is maximum, which is equal to mu s into n. Only the maximum friction force is mu s into n, only this value. Okay, before that it will be less than that. So we have to find the limiting situation in which the acceleration is maximum and the block is just about to slip. So from this you'll get A max as 0.15 g. Right. So if the train is accelerating greater than this value, it will start slipping. Okay. So g is approximately
Yes.
so acceleration is 1.5 meter per second. Right. The interesting thing to note is this value of maximum acceleration is independent of the mass. Whether mass is 100 kg or 10 kg, it does not matter. Got it?
Yeah.
Because mass is cancelling. Okay. What about this one? This is at 15 degrees. It begins to slide. Okay. So what is the direction of friction force? When it is sliding upwards or downwards?
Upwards.
Upward.
Yeah. And there will be weight, mg of normal reaction. Okay. So the axis which you choose will be like this one, x and y. This is convenient. Because only mg has to be resolved in this case. Okay, if you choose axis like this, what is this angle?
90 minus theta.
No, I already told you, no, it's just 15 degrees. 15
Oh
degrees
yeah, sorry sir.
horizontal and the plane. So this is vertical and the normal. Got it? No, remember like that.
Yeah.
Another thing to remember is mg sin theta is down the plane. Where theta is the angle of the plane. So mg sin 15, and this is mg cos 15. Okay, so from that find the value of coefficient of static friction. So n equal to mg cos 15, and then friction force is how much?
ms
Mu,
and msn.
mu. This symbol is
Um.
the Greek symbol. It's
Oh, okay.
almost like mu. Okay. So this is true because the friction force is maximum. It is just about to slide, begins to slide. Only when it's begin to slide, the friction force is maximum. That's why it's mu into s, mu s into n. That is equal to mg sine 15. All right. How do you find mu now?
Mg sine 15 by mg cos 15.
Yeah, you just have to divide these two. Mg will cancel, so this tan 15. Is that clear?
Yeah.
Okay, in general, mu s is tan theta. If theta is inclination of the plane. Okay, so this angle theta is called angle of repose. Okay, so we have an inclined plane, gradually increase theta so that it starts sliding. When it starts sliding, the value of theta will be such that tan theta is mu into s. Sorry, mu s, static friction, coefficient of static friction. This angle theta at which it starts to slip is called angle of repose. Okay, so in general, mu s is tan theta. Here theta is 15, so it's tan 15. Is it clear?
Yeah.
Okay, next is rolling friction. You might already have some idea of rolling friction. So, what is rolling friction? So we have a wheel, okay, and this is the surface road or something. Okay, so what is rolling friction between which two surfaces? Bhavya,
Sir.
rolling friction is between which two surfaces? Your mic is off.
Yes sir.
Rolling friction is between which two surfaces?
Sir, just a second.
So the rolling friction would be towards the right if if the object is moving towards the right.
That's why is your mic going off? Sorry, Bhavya, the mic is going off.
Sir, volume is coming less.
Uh, that's okay, but why is it going off? Right. So, see, there is an axle here, no? In the middle, there is an axle. Okay. You are doing unnecessary things. That's why. there is axle in the middle. So the friction force between this axle and this is like a disc or drum, right? And the middle thing is axle. Okay, so the friction force between this axle and this disc will contribute to the rolling friction. Okay, so sliding friction is between the tire and the road. Then there is no slipping. Okay, so and this contact is metal contact. Both are metal. Axle and the disc. That's why the rolling friction is lesser compared to sliding friction. Sliding friction is between the tire and the road, where the roughness is high. Okay, so that is why in general the rolling friction is less than the sliding friction. Bobby, your mic is still off. So is it clear?
Yeah.
Okay. Okay, let's solve this problem. Here is saying kinetic friction, so it's already in motion. So this mu A is 0.04. Okay, what is the tension in the string? We have to find T. G is 10.
So we can apply second law.
Yeah, you just have to draw free body diagram. You always had a second law when the things are in motion. So basically, you have to get the forces correctly. So, yes. So acceleration is towards right?
Yeah.
So what is the force in the right direction?
So there will be acceleration.
No, T minus Fk, that is equal to m into A. Okay, where m is the mass of the 20 kg. 20 into A, and tension we have to find out, and the friction force is mu k into normal reaction.
Sir is tension. Sir is tension 27 Newton.
How did you find out?
Sir, by the method you are doing that only.
Yeah, but you have to see there
And
are
calculator.
two unknowns. Now acceleration is not known, so you have to find acceleration.
Yeah.
So n is what? 20 into g, right? Okay, so you get one more equation from this 3 kg block. That is third weight is what? 3 kg, right? So this 3 into g minus t equal to 3 into a. So this is equation 1.
बंद कर दो switch को बंद कर दो. Very good.
This is equation 2. So use the two equations.
Sir, we'll get 27, around 27, I think.
G is 10.
And other one we'll get sir, other one is like 1 meter per second square.
This is the other one. The acceleration.
Yes, sir, acceleration.
Tension, did he ask to find? He didn't ask. What is the
Yes, I did.
tension? Okay. Are you getting the same answer? Daksh?
Sir, I haven't gotten an answer yet.
Tension is 27.1, acceleration is 0.96. This is what you
Sir,
get.
why
Huh?
weird values?
Got it right?
Yeah, I got it.
Okay. So there are two equations basically, 1 and 2, and two unknowns.
We have to solve simultaneously, right?
Yeah. First you can add them, t will go away, only acceleration will remain. Okay. So acceleration is 0. Tension is okay. Daksh, done?
Yes, sir.
Okay. Okay. Next is circular motion. So what is circular motion?
Sir, we've done this, right?
We did this for different situation. Spherical pendulum, pendulum, right?
Okay.
Okay. So what is circular motion? Yeah.
Motion in a circle.
Yeah. So the path is circle. Okay. So here there is a road which the car is moving. So this is a circular road, right? So if you draw the free body diagram of the road, sorry, of the car, these are the forces. One is the weight, normal reaction, and the friction force. So why is the direction of friction force towards left? Bhavya?
Sir, because it is moving that way. It's
No.
moving towards right, so friction force will be left.
See, it's trying to move this way. Okay, so there'll be the thing will try to slide this way, readily outward, and try to circle. Okay, the tendency of this thing is to go straight. There is no turning over the wheels.
Tangent.
Yeah, it will move, try to move tangentially. You are turning the wheels such that the direction is this way. There will be a force which is trying to move it away from the center. So that force is compensated by the friction.
Yes, sir.
That is it clear?
Yes, sir.
When you're trying to move the circle, there is a force which is trying to push it away from the center. So the friction force will try to oppose that. So the friction force gets so from this you get the direction of friction force. Now, what about this second part? What is the difference in this one? In the second part, what is the difference? Don't scribble. In B, what is the difference compared to A?
Sir, I'm not getting.
You're not getting the question, or
Yeah, I'm not getting the question.
A and C. A there is some car, no, and B there is a different car. So what is the difference from the figure of A and B? Here, what is the value of theta in the A? This is a level road. Here theta is 0. Okay, so this is the earth surface, and this is the road. So road at an angle. Okay,
Okay.
okay. So that's why mg is vertically downwards. Normal reaction is perpendicular to the road. Okay, and acceleration is always towards the center. The circle will be like this. Okay, and this acceleration is towards the center, and the friction forces along the surface of the road towards the center. So the normal reaction now will have two components. N cos theta balancing mg and n sin theta will be towards left. Okay, so that this angle is theta. Is it clear?
Yeah.
Theta is angle between horizontal and plane. This is vertical and normal. Correct? No?
Yeah.
So this is a free body diagram. Okay, so now we can write the two equations, one in the horizontal direction, another in the vertical direction. Right, because if you take horizontal vertical direction, then there's only one force for which we need components. Already we have, okay, both you have to resolve, both friction force and the normal force. He has got F sin theta, F cos theta, and similarly N cos theta and N sin theta. Okay, when theta is 0, normal reaction, the entire normal reaction is balanced by the mass, and the friction forces entirely towards the horizontal direction. This will be 0. The vertical component of the friction force will be 0. Okay, here in this case, the radially acting force, friction force, friction involves mu into n. Right, in this way, towards the right. Okay, let us solve this problem. Because the cyclist is here, the forces acting on him are the friction force will be towards the center. Okay, because of it, he's accelerating towards the center. Okay, the friction force is equal to mass into acceleration. What does suffix c imply? Bhavya put
So,
acceleration as a suffix c. C is what? The centripetal acceleration.
Centripetal.
It's towards the center. Centripetal acceleration just change the direction of the velocity, not the magnitude.
Yeah.
Okay. Force acting on the side is force, which is mass into acceleration, and friction forces.
Yeah, he has told me that, right? No, he didn't tell me that.
Mu is into n, and n is m. Okay. So mu s into g is
I know. Now,
centripetal
I know why
acceleration.
he yeah.
Okay. Its linear speed is, and this is v square by r. Centripetal acceleration is related to the linear speed as v square by r. Okay. So v square by r is how much?
V square by r is 18 kilometer per hour.
to convert to meter per second. Is 5 meters per second. So V square by R is
25.
25 by 3.
8.3.
No, that's okay. Mu s into G is mu s is 0.1 into G is 10. So this is 10. Right. So this is so the friction force maximum. Friction force maximum is 10 Newton.
Yeah.
Hold on. No, mu s into G I need, no, not the friction. Okay.
So that should be given the centripetal force.
Hold on.
So
No,
why is 0.1 into 10 I'm 10?
mu s into G.
So why is it written that 0.1 into 10 is 10?
1 mu s into G. Okay.
That's
So that way maximum
mu s into G
friction
is
would
1,
be
right?
1.
So acceleration is V square by R. So V square by R is 8 point something. So it will slip.
So that way the maximum friction force would only be 1.
Yes.
Written 10.
Maximum, not the maximum friction force. Maximum of mu s into G. You have to multiply by mass to get the friction force.
Yes, sir.
there is no.
Yeah, the cyclist will slip.
Yeah, I had solved like this all only. The frictional force should be greater than the centripetal force, right?
Yes.
But that is not met.
Yeah, friction force. See, from this we get the maximum acceleration AC. That will be less than what is actually happening here. See, this will imply AC max for not to slip is 1 because you are putting maximum friction force, and but the actual centripetal acceleration is 8 point something. Okay, which is greater than 1, so that's why it is slow. Is it clear?
Yes, sir.
Bhavya?
Sir, yes, sir.
Okay, what about this one? So this way of creating a track at an angle theta, it's called banking. Okay. So bank road means this one where there is a slope. Level road is this one, the first part E. Okay. Okay, there are two parts. One is optimum speed to avoid wear and tear, and the maximum speed to avoid slipping. Okay, so you have to understand these two situations.
It hurt your eye? No.
Okay, so suppose the car is not moving. Suppose the car is at rest. So what is the direction of friction force? Hello?
Yes, sir.
What is the direction of friction force when the car is not moving? Down the plane or up the plane?
Up.
Yeah, because
Up
when
the
it's not
plane.
moving, the car will try to move down like a block sliding down an inclined plane. The friction force will be up when the car is not moving. Suppose the car is moving at a very high speed, then the direction of friction force is which way? Suppose the car is moving at a very high speed, then the direction of friction force is which way? This is the first
Down.
case. Yeah. In the second case, it will be down. Because when it's moving at a very high speed, the car will try to move out. Okay, in that case, the friction force in the second case will be downwards. Okay, so friction force one is at low speed, it's at rest and also at low speed. Okay, and at high speed, the friction force direction will change. Okay, so you have to find both the values. Okay, so you
Yes,
just
sir.
have to draw the free body diagram and use normal reaction. Is there any other force? And acceleration is towards the center. Centripetal acceleration. Okay, so write the equations. What are the axes you will choose, Bhavya?
Yes, sir.
What are the x-axis and y-axis you will choose to write the equations? Along the plane, normal to the plane, or horizontal and vertical? What are the axes you will choose? No, just say it. You don't have to struggle. No, that's not correct. You have to choose this as the axis. Horizontal